In kitchens everywhere, a single question continues to divide cooks more than any spice blend or pan choice. What actually makes food unforgettable? Is it the ingredient list, the technique, or something deeper that happens when heat, time, and physics meet intention? Tonight's recipe answers that question by building flavor in layers you can see, hear, and taste, using science rather than shortcuts and patience rather than hype. The process begins not with meat, but with temperature. A thick cut of steak, chicken breast, or even cauliflower steak is removed from the refrigerator and allowed to warm slightly at room temperature. This step is not about breaking rules. It is about reducing thermal shock. Cold food placed directly into extreme heat contracts violently, forcing moisture outward. By allowing the interior temperature to rise gradually, the protein fibers relax, setting the stage for even cooking. A heavy pan is placed over heat and allowed to preheat fully. This matters. Browning is not caused by heat alone, but by sustained surface contact at a temperature high enough to trigger the Maillard reaction. When proteins and sugars interact at roughly 300 degrees Fahrenheit and above, hundreds of new flavor compounds are formed. This is why pale food tastes flat and browned food tastes rich. A neutral oil with a high smoke point enters the pan first. Not butter. Not yet. Oil coats the surface evenly and transfers heat efficiently. As the protein hits the pan, sound becomes the first signal of success. A sharp sizzle means moisture is evaporating instantly instead of pooling, allowing browning to occur instead of steaming. The protein is left untouched. This is where many cooks intervene too early. Movement interrupts contact. Contact creates crust. Crust creates flavor. As the surface browns, internal moisture is driven toward the center under pressure. This is not myth. It is physics. The muscle fibers tighten, squeezing liquid inward like a sponge under compression. Only after a deep golden crust forms does the protein turn. The second side cooks faster, benefiting from residual heat and structural changes already underway. At this stage, clarified butter or ghee is introduced. Butter at the beginning would burn because of milk solids and water. Butter now works because the pan temperature has stabilized, and the protein shields the fat from direct contact with extreme heat. Aromatics follow, not for show, but for fat-soluble flavor infusion. Garlic, thyme, rosemary, or spices bloom gently in the butter, releasing volatile compounds that dissolve into fat and coat the surface of the food. Basting begins, spooning hot butter over the protein repeatedly. This transfers heat gently while layering flavor without overcooking. Once the internal temperature approaches doneness, the protein is removed from heat and allowed to rest. This is not about obedience to culinary school doctrine. It is about pressure equalization. When heat stops, muscle fibers